Hello everybody, welcome into another lesson. So today we are starting the unit on powers, roots, and radicals. In today's lesson we're going to talk about nth roots and rational exponents. So in Algebra 1 we never covered this. Now here in Algebra 2 we're also exploring rational exponents. Technically, every exponent we've done so far from Algebra 1 up through now has technically still been rational. If it's a whole number, it's rational. But sometimes you will also see, what you will see are exponents in fraction form or in decimal form. So what does it mean when you have that? Well, take 4 to the 1/2 power, for example. What the heck does that mean? So 4 to the 1/2 power, that 1/2, that fraction, so the denominator of that fraction is what's called the root index, meaning in this case you would be taking the square root of 4. The numerator is the power that root is raised to. So this is the same as taking the square root of 4 raised to the first power, which we know is going to be 2, right? So the denominator of the fractional exponent is your root index. That tells you what root you're taking. The numerator is the power you're raising that root of the number 2. So fairly simple, really. Alright, so let's say I want to take 8 to the 1/3 power. I'm going to take 8 to the 1/3 power. So what is that? Well, 3 is my root index, so that means I'm taking the cube root of 8 raised to the first power, or simply the cube root of 8, which the cube root of 8 is going to be none other than 2. Alright, let's change it up a bit here. Let's say I take 25 to the 3/2 power. So I'm going to take 25 to the 3/2 power, right? Well, my root index is 2, so that means I'm going to take the square root of 25, but the numerator tells me I'm raising this whole thing to the 3rd power. So what I really have is the square root of 25 raised to the 3rd power. Well, what's the square root of 25? That's going to be 5, then raised to the 3rd power. Well, what's 5 to the 3rd power? That's 125. So 25 to the 3/2 power would end up being 125. Alright, let's say I take 32 to the 2/5 power. So I'm going to take 32 to the 2/5 power. Well, what is that exactly? Well, that denominator 5 tells me my root index is 5, which means I'm taking the 5th root of 32. And then my numerator means I'm raising the 5th root of 32, that quantity, to the 2nd power. That's what that means. Now, what is the 5th root of 32? Well, that'd be 2. So this would just turn into 2 to the 2nd power. 2 to the 2nd power is what? It's 4. So therefore 32 to the 2/5 power would end up being 4. And we got several lessons in this unit, but you're going to need to know this when we go on to the next unit, which talks about exponential and logarithmic functions. That'll be the next unit after this, when we go to solve those. Now, let's work a little bit of reverse here. Let's say I have the square root of 9. The square root of 9, what's my root index here? It's a square root, so my root index would be 2, right? This would be 9 to the what over 2 power? Well, this is raised to the first power, isn't it? So the square root of 9 is the exact same as 9 to the 1/2 power, which would end up giving me 3, of course. So it's good to know how to work in reverse. Now, let's say I take the cube root of 27. I'm going to take the cube root of 27, but I'm going to raise that to the second power. No, I'm sorry, we're not going to raise it to the second power. We're actually going to raise that to the fourth power. I want to change it up a bit. So we're going to take the cube root of 27 and we're going to raise that to the fourth power. Well, what is my root index? My root index is 3 because it's the cube root, right? So take that number under the radical, which is 27. It's my root index, which is 3, so that means the 3 is going to go in the denominator of the exponent, and then this cube root of 27 is raised to the fourth power, so the 4 would go in the numerator of the exponent, which would end up giving me 27 to the 4/3 power. So cube root of 27 is 3, 3 to the 4th is 81. So the cube root of 27 to the fourth power, which is the same as 27 to the 4/3 power, would end up being 81. So let's see here. Let's say one more. I'm going to take the 6th root of 64 and I'm going to raise that to the 5th power. So I'm going to take the 6th root of 64 and raise that to the 5th power. Well, let's write this as a number that has a fractional exponent instead. So, of course, I'm going to take that number under the radical, which is 64. Now, what is my root index? My root index is 6, right? Because I'm taking the 6th root. So that's going to go in the denominator of the exponent. Now, what power is this raised to? It's raised to the 5th power, so that 5 will go in the numerator of the exponent. So the 6th root of 64 raised to the 5th power is the same as 64 to the 5/6 power. Well, the 6th root of 64 is 2, raised to the 5th is 32. So 64 to the 5/6 power would end up being 32. So it's good to know how to work from converting from a number raised to a fractional power to convert that into a root problem, and then vice versa. It's good to know both of those, be familiar with both. So those are actually fairly easy if we're being honest. Now let's talk about some other things here. So let's say we have something like x to the 5th equals 243. So we have x to the 5th equals 243. Now you're probably thinking we need to make this a polynomial and do a bunch of factoring. Well, when we're finding roots, at least for now, we only care about the real solutions. We are only going to care about the real solutions. So to get x by itself, you're going to take the 5th root of x to the 5th, right? So that'd be the same as the 5th root of x to the 5th. But what you do to one side, you got to do to the other. That would equal the 5th root of 243. All right, now, the 5th root, so here's the thing. The 5th root, it's an odd root, right? If your root is odd, it could be any real number under the radical. Odd roots work for any positive or negative real numbers. Because, let's say, for example, I take -2 to the 5th power. That's the same as multiplying -2 by itself 5 times, right? Which would end up giving you -32. So that is why for odd roots, such as a 5th root, a 3rd root, a 7th root, what have you, any real number will work. Thus, you will have only one real number solution. Now, you're going to have 4 other imaginary solutions, but you'll have one real number solution if you have any number under the radical in an odd power root, or an odd number root. Well, the 5th root of x to the 5th, that would just be x. That's going to equal the 5th root of 243, which would end up being 3. So you have only one real solution of x is 3. All right. What about the next one? We have 6x to the 3rd equals negative 1296. And again, we only care about the real solutions. So, of course, we want to get the x to the 3rd by itself, so let's divide both sides by 6. If you do that, you'll get x to the 3rd is equal to, let's take that negative 1296 and divide it by 6. Whatever the heck that is. That's going to be 216. So actually it'd be negative 216. Well, in order to get x by itself, you got to take the cube root, right? But you'll have to do it to both sides. So take the cube root of x to the 3rd. That would equal the cube root of negative 216. And again, let's look at this here. So you have an odd powered root, which means any real number will work under the radical. You'll have exactly one real solution. Now you would have 2 imaginary solutions also, but we only care about the real solutions right now. If it's an odd power root with any real number under the radical, you'll have one real solution. So cube root of x cubed is just x. That's going to equal the cube root of negative 216, which should end up giving you negative 6. So x will actually end up equaling negative 6 in the end. All right, good one. X to the 6th plus 10 equals 10. So we've been given x to the 6th plus 10 equals 10. Well, we want to get that x to the 6th by itself, right? So subtract 10 from both sides, you'll get x to the 6th equals 0. And of course, we want to get x by itself, so you got to take the 6th root, right? So take the 6th root of x to the 6th. That would, of course, equal the 6th root of 0. Now, if you have 0, okay, so first let's talk about if you have a positive number under the radical in an even root. So the root is even, but you have a positive number under the radical, you'll have 2 real solutions. If you have the number under the root, under the radical with an even root, you'll have exactly 1 real solution. Right? And then, of course, if you have a negative number under the radical and it's an even root, you'll have no real solutions. You would be getting into imaginary numbers. But the 6th root of x to the 6th, that's just going to be x. That would equal the 6th root of 0. Well, that's just 0. So literally, x would be equal to 0 in this case. For the real solutions, and actually that's all you would have, because any root of 0, no matter whether it's odd or even, is literally just 0. There's nothing else you can do with it. Okay, so we have the quantity of x minus 4 to the 4th is going to be equal to 81. So x minus 4, that quantity to the fourth, equals 81. So a little bit different. Well, first we want to get that x minus 4 by itself, right? So you got to take the fourth root of both sides. So take the fourth root of x minus 4 raised to the fourth power. That would equal, of course, the fourth root of 81. Now, here's the thing. If you have any positive number under the radical, right? Let's just assume this is going to be positive, and that makes sense. If you have a negative or positive number raised to an even power, such as the fourth power, it'll always be positive, right? If you have an even root, you're going to have two real solutions. So that means you actually have to take both plus and minus the fourth root of 81. If it's an even power, if it's an even root, you're going to have both plus and minus, just like you would for a square root. It would be the same for a fourth root or a sixth root, a hundredth root, what have you. So the fourth root of x minus 4 to the fourth, that would just give you x minus 4. That's going to equal, now, what is the fourth root of 81? That'd be 3. You would actually have plus and minus 3. So we got x minus 4 equals plus and minus 3. Now we got to find both solutions. Add 4 to the others. Add 4 to both sides. X would equal, what's 4 minus 3? That's going to be 1. What's 4 plus 3? That's going to be 7. And if you put those values in, 1 or 7, you get negative 3 to the fourth would give you positive 81. Positive 3 to the fourth would also give you positive 81. So you got two real solutions where x would equal 1 and 7. Now you would have two imaginary solutions also, but again, we only care about the real solutions. So x would equal 1 and 7. Now there will come another time we'll list all solutions, but that's not today. Okay. We have negative x to the seventh would equal 40. So negative x to the seventh would equal 40. Well, we want to get x to the seventh by itself, right? So we need to divide both sides by negative 1, so that would turn into x to the seventh would equal negative 40. And of course, to get x by itself, you got to take the seventh root, right? So take the seventh root of x to the seventh. That would equal also the seventh root of negative 40. All right, so seventh root of x to the seventh is just x. Now, on the right-hand side, any real number that that's under the radical that has an odd root will have exactly one real solution. So let's find out what the seventh root of negative 40 is. Now, most calculators only go up to square root, maybe cube root if you're lucky. How you're going to have to put this in your calculator is in parentheses that minus 40 with the caret symbol, and then in another parentheses 1/7. That's how you would put that into your calculator. So negative 40, that caret symbol, and then in another set of parentheses 1/7. That's how you would solve that. We're going to round the result to about 2 decimal places. So let's take the seventh root of negative 40. So this is where knowing how to convert to rational exponents from a root is very useful. So we're going to take negative 40 to the 1/7 power, And that would give you approximately negative 1.69. So the seventh root of negative 40 is approximately equal to negative 1.69. That's about what you would get, negative 1.69. Okay, I only have a few more here. I have about 4 more. So let's see, we have negative 12x to the fourth is going to be equal to negative 48. So negative 12x to the fourth is equal to negative 48. Well, let's get that x to the fourth by itself first. Divide both sides by negative 12, you get x to the fourth is equal to positive 4. So now we have x to the fourth equals positive 4. Next step is get x by itself, so take the fourth root of both sides. So the fourth root of x to the fourth is going to equal, you'll start out with the fourth root of 4, but remember something. If you have any positive number under the radical, any positive number, you actually have both a plus and a minus, right? X would actually equal plus and minus the fourth root of 4 because you're going to have 2 real solutions. So fourth root of x to the fourth, of course, would equal x. That's going to be approximately equal to both plus and minus the fourth root of 4. So you would get positive and negative 1.41. So you would get 2 solutions where x is approximately equal to positive and negative 1.41. That's about the fourth root of 4, approximately. All right, I have 3 more. And again, keep in mind, those are only real solutions. All right, x plus 12 to the third power is going to equal 21. So we have x plus 12 to the third power is equal to 21. Well, let's start out by getting the x plus 12 by itself, right? So you got to take the cube root of x plus 12 to the third power, but that's also going to be equal to the cube root of 21. All right, well, here's the thing. So any real number under the radical that has an odd root has exactly 1 real solution. So the cube root of x plus 12 to the third power would just turn into x plus 12. That means you're just going to have only the cube root of 21. And unfortunately, 21 doesn't break down evenly, nor do any of its factors. There's no perfect cube of any of the factors. So that means x would equal negative 12 plus the cube root of 21. That would be the exact solution, but if you're going for a decimal approximation, you can put that in too. So first, let's figure out what the cube root of 21 actually is, or what it approximately is. It's approximately 2.76. which would give you about negative 9.24. So x would be approximately equal to negative 9.24 once you do the decimals. And if you put that in, you would end up getting about 21. If you put that in for your x value, you would get about 21. Alright, should just have a couple more here. Yep, I have two more. So we have x to the third minus 14 equals 22. So we've been given x to the third minus 14 equals 22. Well, we want to get that x to the third by itself, right? So let's add 14 to both sides. So that would end up giving you x to the third equals 36. Now we just want to get x by itself, so take the cube root of both sides. Cube root of x to the third would equal also the cube root of 36. And since it's an odd power, we have only one root. Only one real root, I should say. So obviously the cube root of x to the third is just x. But what is the cube root of 36 approximately? Well, 36 isn't a perfect cube, nor are any of its factors for that matter. So let's go ahead and try to figure this out. It's approximately 3.30 or 3.3. So x would be approximately equal to 3.3 if you put that into your calculator. And I have one more here. Alright, let's see. X to the 8th minus 25 equals negative 10. So we've been given x to the 8th minus 25 equals negative 10. Well, we want to get the x to the 8th by itself, so add 25 to both sides. So you would end up with x to the 8th would equal 15. So you get x to the 8th equals 15. Alright. Well, we just want to get x by itself, so you definitely have to take the 8th root of x, right? So you'll have the 8th root of x to the 8th is what I meant. Now keep in mind that even roots are only defined in the real numbers for 0 or positive. If you have any positive number under the root sign and you have an even root, you're going to have two real solutions. So that means we're actually going to take plus and minus the 8th root of 15. So the 8th root of x to the 8th would equal both plus and minus the 8th root of 15. Well, 8th root of x to the 8th is simply x. Now let's figure out some decimal approximations for that 8th root of 15. So let's see. That would give you both plus and minus approximately 1.40 or 1.4. So x is approximately equal to plus and minus 1.4. Those are your two real solutions. And if I put either the positive or negative into the original, I'll get a positive number. So that's why you get two real solutions, just like you would for a square root. So that's it for this lesson. Next lesson, we're going to talk about some properties of rational exponents. Like, we're going to go over why when you multiply the square root of the one base times the square root of the same base, why that works. Or why when you square a square root, it cancels out the square root also. So I hope everybody has a great night. Take care.